Dear learners, welcome to our first lecture on physical pharmaceutics. Have you surprised sometimes why some medicine work faster than others? Have you surprised sometimes why some medicine work faster than others or why certain drugs dissolve better in body from quick relief? That is a well answer physical pharmaceutics. From solubility to pH buffer and isotonic solution. In this lecture we cover that every topic play a key role in how drugs are designed to reach and act in the human body. Physical pharmaceutics is a branch of science that help us understand how drug behave physically and chemically once they enter in body. Whether you are preparing for GPAT, NIPER or any other competitive examination, this lecture for you. So in unit first, solubility of drugs. Unit first is a solubility of drugs. First in that solubility expression, mechanism of solute solvent interaction, ideal solubility parameter, quantitative approach to the factor affecting solubility of drugs, diffusion principle in biological system, solubility of gas in liquid, solubility of liquid in liquids, binary solution, ideal solution, Raoult's law, real solution, partially miscible liquids, critical solution, temperature and applications, distribution law and its limitations and applications. So this is the unit 1 syllabus. So in that chapter we learn about various multiple choice questions, expected for competitive examination. So first question, that is, which following solubility expression describe the concentration of solute? Which following solubility expression describe the concentration of solute in solvent? Solubility, the amount of substance or the amount of solute dissolved in solvent, that is called solubility. Solubility expression means that how much amount, how much solute present in that solution. That finding means the methods. Option A, normality. Option B, molarity. Option C, both A and B. And option D, diffusion rate. So both A and B is the correct. Normality and molarity express solubility. Second question, which of the following interaction is primarily responsible for dissolution of ionic compound in water? Option A, London dispersion force. Option B, hydrogen bonding. Option C, ion dipole interactions. And option D, none of this. Which of the following interaction is primarily responsible for dissolution of ionic compound in water? So option C, ion dipole interaction is the correct answer. Next, which of the following is considered an ideal solution in terms of solubility? Ideal solution. When we said solution, solute dissolved in a solvent, that is called solution. Or solution is a homogeneous single phase. Option A, solution where the solute and solvent have same chemical nature and intramolecular forces. Option B, solution that exhibit a significant temperature change during the dissolution. Option C, solution that is a completely miscible and non-volatile. Option D, a solution with large difference in polarity between solute and solvent. Question in that, which following consider an ideal solution in terms of solubility? So option A is the correct, a solution where the solute and solvent have same chemical nature and intramolecular forces. Next question, which of the following factors most significantly increase solubility of drugs. Influence or increase particle size, only particle size. Option B, nature of drug. Option C, temperature. And option D, all of the above. So smaller the particle size, that also improve the solubility. Nature of drug, that also affect, means lipophilic or hydrophilic. And temperature, higher the temperature, higher the solubility. So which of the following most significantly influence the solubility of drugs? So option D is the all of the above, because particle size smaller, the solubility also increases. Lipophilic drugs, solubility also increases. Temperature increases, solubility also increases. Next, which of the following is the primary mechanism of drug absorption? Lipophilic drugs. Option A, active transport. Option B, carrier transport. Option C, passive diffusion. Option D, pinocytosis. So active transport, in that water soluble drugs have passes. Carrier transport, there are also water soluble drugs, vitamins. Passive diffusion is the only answer, that is maximum 90% drugs, lipophilic drug crosses this mechanism. Next, which of the following is a true regarding solubility of gases in liquid? Option A, solubility decrease with increasing temperature. Option B, solubility increase with increasing pressure. Option C, solubility is independent of pressure. And option D, solubility decrease with decreasing temperature. So option B is the correct. Solubility increases with increasing pressure. Next, 7 question. What is miscibility means? Miscible means soluble. A, option A, the ability of one liquid to dissolve in another to form a homogeneous solution. Option B, the ability of liquid to settle into layers. Option C, the ability of liquid to react chemically. And option D, the ability to form solid. Miscible, partially miscible, complete soluble, complete miscible. Complete means whole soluble. Partial means small amount. The question is, what does miscibility means? The option A is the correct. The ability of one liquid to dissolve in another to form a homogeneous solution. Miscible, soluble. Next, Raoult's law state that the partial vapor pressure of each volatile component in solution is directly proportional to option A, total vapor pressure of the solution. Option B, the mole fraction of the component in the solution. Option C, the molecular weight of the solute. And option D, the density of solvent. Raoult's law state that the partial vapor pressure of each volatile component in a solution is directly proportional to the mole fraction of component in the solution. B is the correct answer. Next questions. Which of the following is a true for real solution compared to ideal solution? Real solution. Option A, homogeneous mixture consisting of two or more chemical substances. Option B, example, simple sugar in water. The solution which does not obey Raoult's law over the entire range of concentration, then it is called as non-ideal solution. Option D, all of the above. So all of the above is the correct answer, because homogeneous mixture consisting of two or more chemical substances. Example, simple sugar solution in water, that is also homogeneous, means single phase. And the solution which does not obey the Raoult law, that is called also ideal solution. Next question. Which of the following pH of liquid are partially miscible? Partially miscible. Miscibility means soluble. Partial means not completely soluble. So option A, water and ethanol soluble. Water and methanol also soluble. Water and vegetable oil, that is C is the correct answer. Water and vegetable oils partially miscible each other. Next question, the critical solution temperature, CST temperature. Option A, the temperature at which solution forms solid. The temperature at which B, the temperature at which two partially miscible liquid become completely miscible at all proportion. Option C, the temperature at which Raoult's law no longer holds true. Option D, the temperature at which solution reaches its maximum solubility. So option B is the correct. The temperature at which two partially miscible liquid become completely miscible at all proportion. Next, which of the following is a limitation of distribution law? Nernst distribution law. Distribute. Option A, it is only applied to liquid-liquid system. It assumes the solute is distributed evenly between the two solvent. It apply only to ideal solution. And D, none of this. Which of the following limitations? So ideal law limitation, it assume the solute is distributed evenly, mean same concentration between the two solvent. That is the limitations. Next, which of the following application make use distribution law? A, determine the partition coefficient of drug between oil and water. Application related to pharmacology, chemical separation process and analytical techniques, particularly where two immiscible solvents are involved. Option C, estimating the solubility of gas in a liquid. And option D, none of this. So which of the following application make use of distribution law? Determine the partition coefficient of drug between oil and water. Application related to pharmacology, chemical separation processes and analytical techniques, particularly where two immiscible solvents are involved. And estimating solubility of gas in a liquid. So first, determine the partition coefficient of drug between oil and water, two solvent. Another, application related to pharmacology, chemical separation processes and analytical techniques, particularly where two immiscible solvents are involved. So both answers are correct, both A and B. But there is no options, both A and B is correct. So answer A is the correct. Determine the partition coefficient of drug between oil and water first. Then later applications, pharmacology, chemical separation processes and analytical techniques, particularly where two immiscible solvents are involved. So solubility, the maximum amount of solute dissolved in a given solvent at specific temperature. Quantitative terms, solubility is defined as the maximum amount of solute that can dissolve in a given amount of solvent at specific temperature and pressure, forming a homogeneous solution. In qualitative terms, solubility refers the general ability of substance solute to dissolve in a particular solvent without needing exact amount. This frequently describe whether substance dissolved or not and to what extent it dissolved based on observation and comparison. Example, highly soluble, freely soluble, etc. Solubility, amount of solute and solvent to form a solution. Types of solution, saturated solution, unsaturated solution and supersaturated solution. So basic difference, saturated means the point at which no more solute can dissolve in the solvent at a given temperature and pressure. A saturated solution is equilibrium with undissolved solute. Unsaturated solution, a solution that contains less solute than the maximum amount of dissolved at a given temperature and pressure. Another, supersaturated solution, a solution that contains more solute than it can be ideally hold at a given temperature and pressure. This occurs under the special conditions, that is called as supersaturated solution. Saturated solution, the point at which no more solute can dissolve. Saturated, solute and solvent, solute mixed in a solvent to form a solution. Saturated solution means the point at which no more solute can dissolve. Unsaturated means less solute. And supersaturated means the solution that contains more solute than it can ideally hold the given temperature and pressure. Importance of solubility in pharmacy, bioavailability and absorption. Improve the bioavailability and absorption of drug design and formulation, to select best solvent for drugs, to know about the intermolecular process of drugs, to identify drug aqueous solubility. Another, targeted drug delivery techniques to improve solubility include the use of nanoparticles, liposome, cyclodextrin complex to enhance solubility and help the delivery of poorly soluble drugs. Solubility expression: very soluble less than 1 part, freely soluble 1 to 10 parts, soluble 10 to 30 parts, sparingly soluble 30 to 100 parts, slightly soluble 100 to 1000 parts, very slightly soluble 1000 to 10,000 parts, practically soluble more than 10,000 parts. Practically insoluble, not soluble, you have to correct it, practically insoluble. As per quantitative expressions, molarity, first question asked which solubility expressions. So molarity, parts per million, and normality, that are the solubility expressions. Tricks. So competitive examinations want to clear that times tricks is important. So this is some example tricks and tips. Distribution law, it also called as Nernst distribution law. Solute, distribute between two immiscible solvents. Rates according to concentration. Proportional, the ratio of solute concentration is constant at equilibrium. Limitations: saturated at high concentration, the law no longer holds. Break, the law is not valid, non-ideal condition. Rules: deviation occurs in extreme condition, example concentration and temperature. And applications: extraction, partitioning, and drug delivery. For extraction of herbal drugs, partitioning, separation, different solubility in two phases, drug in pharmaceutical formulation to optimize bioavailability. So we turn to the second unit of physical pharmaceutics 1, state of matter, properties of matter, solid, liquid, and gases. State of matter, changes in state of matter, sublimations, desublimations, latent heat, vapor pressure of sublimation, critical point, inhalers, relative humidity, liquid complexes, physicochemical properties of drug molecule, refractive index, optical rotation, dielectric constant, dipole moment, dissociation constant, determination, and application. These are the second unit syllabus of physical pharmaceutics 2. Let's turn to the multiple choice questions. State of matter. First question, that is, which of the following represent characteristics of gas? Option A, definite shape and definite volume. Definite shape but indefinite volume. C, indefinite shape and indefinite volume. Definite volume but indefinite shape. So option C is the correct, indefinite shape and indefinite volume of gas. Next, the fluid exit above the critical point is called supercritical fluid. The law which relation between volume and pressure of gas constant temperature is called. The law which relation between volume and pressure of gas constant temperature is called A, Henry's law, B, Boyle's law, C, Charles' law, and option D, Gay-Lussac law. So option B is the correct, Boyle's law. Next, refractive index cannot be measured. Refractive index cannot be measured. Option A, Abbe's refractometer, B, Oostwald viscometer, P block refractometer, D, immersion refractometer. Option B is the correct, Oostwald viscometer. It determines the viscosity. So this is the knot. Next, what happens during the process of sublimation? So option A, solid turns into the liquid. Solid turns into the gases without becoming liquid. C, a gas turn into liquid. Option D, gas turn into the solid without becoming a liquid. So sublimation, you have to remember, sublimation in that solid turn into the gas without becoming a liquid. Example, camphor. When we heating the camphor, that camphor directly converted into gases without converting to the liquid. That is called sublimation. So sublimation, solid turn into gases without becoming a solid. Next, the critical point of substance is defined as A, the temperature at which liquid and gas become indistinguishable, the point at which substance can exist in both solid and liquid state, the temperature at which substance changes from gas to liquid. Option D, the point at which the liquid reaches its maximum volume. Critical point. Option A is the correct. The temperature at which liquid and gas phases become indistinguished, means cannot identify. That is called as critical point. Next, which of the following is a property of liquid crystal? Which of the following is a property of liquid crystal? A. They are always solid at room temperature. They possess properties of both liquid and solid. They are always transparent. D. They do not have ordered structure. So they possess properties of both liquid and solid. Liquid crystals. Crystals are solid. Liquid. So this both properties liquid and solid. Next, which type of mixture forms at eutectic points? Option A, a mixture with uniform composition throughout. Option B, a mixture that freezes at a constant temperature and composition. Option C, a mixture where all components freeze at different temperature. Option D, a mixture with no specific freezing point. A mixture that freezes at constant temperature and composition. That is the correct answer. Next, what does the refractive index of substance measure? What does the refractive index of substance measure? A. The degree to which substance can absorb light. B. The speed of light in medium compared to air. C. The ability of substance to rotate plane polarized light. The electrical conductivity of substance. The speed of light of medium compared to air, refractive index. The speed of light in medium compared to air, it can be measured. Next, which property of molecule related to its ability to interact with an electrical field? Option A, dipole moment. Option B, refractive index, and option C, dielectric constant, and D, optical rotation. Question, that is, which property of molecule is related to ability to interact with electrical field? That is the dielectric constant. Option C is the correct answer. Next, what is the dipole moment of molecule? A, the total change of molecule. Option B, the separation of positive and negative charge within the molecule. Option C, the energy required to break a molecule into ions. Option D, none of these. So here B is the correct answer. The separation of positive and negative charge within the molecule. Dipole. Positive and negative charge in the molecule. Next, 12. The dissociation constant. The dissociation constant of uric acid is A. The equilibrium constant for dissociation of acid. The rate constant for dissociation of acid. C. Solubility of product of acid. And D. Concentration of undissociated acid. So, equilibrium constant of dissociation of acid. Next, which of the following is true for an aerosol inhaler? Which of the following is a true aerosol inhaler? It delivers a drug in solid form. It is used to release the drug in liquid form. It delivers the drug in fine particles or droplet for inhalation. And D, none of this. So C is the correct answer. It delivers the drug, fine particles or droplet for inhalation. Aerosol is a pressurized dosage form, propellant. Next question number. The optical rotation of molecule. The optical rotation of molecule is result of option A, the angle at which light passes through a medium. Option B, the ability of substance to absorb light. Option C, the rotation of plane polar light by chiral molecule. Option D, the bending of light due to the changes in density. So option C, the rotation of plane polarized light, optical rotation. Next, the latent heat fusion. Latent heat fusion. Option A, heat required to convert solid to gas. The heat required to convert liquid to gas. And option C, the heat required to convert solid to liquid. And the heat required to changes temperature to substance. So option C is the correct answer. Heat required to conversion solid to liquid. Heat, latent heat of fusion. Next, the process of vaporization involve vaporize. Option A, that is conversion of solid to liquid. B, conversion of liquid to solid. Option C, conversion of liquid to gas. And D, conversion of gas to solid. So option C again correct. Conversion of liquid to gas. Vaporization. Vaporization or evaporation. When we heating of that liquid get converted to vapors or evaporate. It is called as vaporization. Next, which of the following factors affect the vapor pressure of liquid? A, the molecular size of liquid. B, temperature of the liquid. C, density of liquid. And D, amount of dissolved gas. So temperature of the liquid. So higher the temperature, higher the vapor. Vapor pressures. The following factors affecting the vapor pressures of liquid. So temperature, that is the correct answer. So state of matter and properties of matter. Matter means anything that has mass and require space based on its compositions and properties. Matters can classify solid, liquid and gases. Matters classified: pure substance based upon solubilities, mixtures of substance, pure substance elements, compounds based upon solubility, solid, liquid and gases. Mixture, homogeneous mixture, single phase, and heterogeneous mixture, that is biphase. Suspension and emulsions, else I have know about. So that is the types of matter. So in competitive examinations, you have to need to prepare your notes. Properties of matter, changes in state of matter, you have learned about. Sublimations, sublimation in that solid is converted into gases without turning to the liquid. And deposition, gas converted into solid, and solid to convert into liquid, that is melting. Freezing also, freezing opposite liquid to solid, that is the freezing point. Questions ask freezing point means what? Freezing means liquid to solid, and melting means solid to liquid. Vaporization means liquid to gas, and condensation, gas to liquid, that is the condensation. So shape question that is asked, gas is indefinite shape and indefinite volume. The question is asked. Another question is asked, aerosol. Aerosol is a pressurized package in which drug is dissolved or suspended in a compressed or liquefied gas. Solid, crystalline solid, amorphous solids. Boyle's law, Charles law have here. Changes in state of matter, melting, change from solid to liquid. Vaporization, changes from liquid to gas. Condensation, change from gas to liquid. Solidification, freezing, change from liquid to solid. Sublimation, change from solid directly to gas. And deposition, change from gas direct to solid. Next, eutectic mixture. Eutectic mixture is a mixture of two or more solid substance that when combined form specific ratio that melt at lower temperature than the melting point of individual compounds. Eutectic mixture is a mixture of two or more solid substances when combined form specific ratio that melts at lower temperature than the melting point of individual compounds. Powders, manufacturing of powder dosage form, that times eutectic mixture is important. Two solids, powder is a solid dosage form used for externally and internally in first year syllabus, that is the powder topics. So eutectic mixture used to detect physical incompatibility. So incompatibility means unstable of that drugs, not compatible each other. Physical incompatibility, therapeutic incompatibility and chemical incompatibility, that is also types of incompatibility: physical, chemical and therapeutics. So this eutectic mixture is helpful for detect physical incompatibility between drug and excipient during pre-formulation. Another, eutectic mixtures are commonly used in drug designing and delivery process for various routes of administration. Knowledge of eutectic points of powder component is important during manufacturing process such as tableting. During pharmaceutical analysis, understanding eutectic mixtures can help the identification of compounds having similar melting points. So this is about eutectic mixture. So there are different law of gases: Boyle's law, Charles law, Dalton law of partial pressure, combined gas law, Gay-Lussac law, Avogadro's law, different gas law. So ideal gas law equation PV and RT. Boyle's law: pressure is inversely proportional to volume, temperature is constant. But in Charles law, pressure is constant, which is directly proportional, volume is directly proportional to temperature. Here, pressure is directly proportional to temperature, Gay-Lussac law. Avogadro's law: volume is directly proportional to the number of molecules. So they have to remember the different gas law. Next, physicochemical properties of drug molecule. Deep knowledge of physical and chemical properties of drug molecule is particularly important for any formulations designing. Physical properties of drug is responsible for its actions. So starting we said that sometimes surprise why some medicine work faster than other, or why certain drugs dissolve better in body for quick relief. So this is the answer of physical pharmaceutic physicochemical properties: particle size, charge, chemical properties. So these are the different properties of physicochemical properties: solubility, partition coefficient, melting point, stability, hydrogen bonding, dissociation constant, ionization of drug, isomerism, stereochemistry, redox potential. So this is the end of second unit. Next, turn to the third unit: surface tension and interfacial tension, surface and interfacial phenomena. In that, liquid interface, surface and interfacial tension, surface free energy, measurement of surface and interfacial tension, spreading coefficient, liquid interface, surface active agent, HLB scale, solubilization, detergency, adsorption at solid interface. So these are the syllabus of unit 3rd. Next, turn to the GPAT MCQs: surface tension and interfacial tension. So first question turn: what is the primary difference between surface tension and interfacial tension? Surface tension and interfacial tension. Primary difference between surface tension and interfacial tension. A. Surface tension refers to force per unit length at surface of liquid, while the interfacial tension refers to the force between two different phases. B. Surface tension occurs between two liquids, while interfacial tension occurs between liquid and solids. C. Surface tension is associated with solid phase, while interfacial tension is associated with gas phase. D. There is no difference between surface and interfacial tension. So correct answer: surface tension refers to force per unit length at surface of liquid, while interfacial tension refers to the two different phases. Next question: surface free energy of liquid measure. A. The internal energy of liquid. B. The energy required to increase the surface area of liquid. C. The amount of heat required to vaporize the liquid. Option D. Energy required to break the intermolecular bonds in the liquid. The energy required to increase the surface area of liquid. Energy. Surface free energy of liquid is measured. The energy required to increase the surface area of liquid. Next question: which method is used to measure surface tension? A. Drop weight method. B. Ostwald method. D. Drop number method. And maximum bubble pressure method. So question that is asked: which method is not used to measure surface tension? So drop weight method is correct. It can measure the surface tension. Drop number also. Maximum bubble pressure method also. But Ostwald method that determine the viscosity. So that is the not method. Next, the hydrophilic lipophilic balance HLB scale is used to measure. Option A. The solubility of compounds in water. B. The emulsifying properties of surfactant. Option C. The acidity or alkalinity of a solution. D. Viscosity of surfactant solution. Option B is the correct. The emulsifying properties of surfactant. B. Questions: The surface active agent or surfactant is characterized by surface active agent, the agent which reduces the surface tension. That is called as surface active agent. Option E, high viscosity in water. B, having both hydrophobic and hydrophilic parts. Being highly soluble in water but insoluble in oil. And D, high surface tension. B is correct, having both hydrophobic and hydrophilic parts. Next questions. Which of the following is the primary application of surface active agent surfactant? A, they act as emulsifier and detergent. B, they increase the viscosity of solution. C, they decrease the evaporation rate of liquid. D, they increase the boiling point of liquid. So option A is the correct. The act as an emulsifier and detergent. Next, which of the following true solubilization process in the content of surfactant? Which of the following true for solubilization in contents of surfactant? Surfactant increase the solubility of water soluble substance in water by forming a micelles. B, surfactant decrease the solubility of water in soluble substance in water. C, solubilization is only possible in non-aqueous solvent. And D, solubilization does not involve surfactant. So option A is the correct. Surfactant increase the solubility of water insoluble substance in water by forming a micelle. Because solution, it acts as a solubilizing agent. In suspension, it acts as a suspending agent, and emulsion, it acts as a emulsifying agent. That is the role of surfactant, to improve the solubility. Once solubility enhance, then pharmacological actions also enhance, means bioavailability also enhance. So that's a correlation. Next, it content of detergency. What is the role of surfactant? A, they break down in oil into smaller particles than can be removed by water. B, they neutralize acid in cleaning process. C, they act as a solvent for dyes and pigments. D, they bind with dirt particles and increase the viscosity of solution. So first, detergent break down oil into smaller particles that can be removed by water. So option E is the correct. 9. Adsorption at a solid liquid interface refers to A, the accumulate of solid molecule at the interface of two immiscible liquid. B, the attraction of solid molecule to the surface of solid from liquid phase. C, the migration of ions from solid to liquid phase. D, the distribution of solute evenly in a liquid phase. So option B is the correct. Next, the drop count method is commonly used to measure. The drop count method is commonly used to measure A, refractive index of liquid, B, surface tension of liquid, viscosity of liquid, and D, none of these. So drop count method is measure surface tension of liquids. So some surface tension, the force in dynes acting on surface of liquid in right angle to any time of length 1 centimeter. Dynes per centimeter or Newton per meter, that is the unit of surface tension and interfacial tension. Interfacial tension, the force per unit length at a boundary between two immiscible liquids or between liquid and solids. Surface free energy, excess energy at the surface of material due to the molecular interactions. Spreading coefficient, indicate ability to liquid spread over another liquid at an interface. Surface active agent, the agent which reduces interfacial tension. Mechanism of action, surfactant have hydrophilic, water loving, and hydrophobic, water repelling parts, and which reduce surface tension and help emulsify or solubilize substance. HLB scale, quantify balanced hydrophilic lipophilic parts of surfactant molecule based upon molecular structure used to select surfactant. Solubilization, the process by which surfactant increase the solubility of poorly soluble drugs. Detergency, ability to remove dirt or from surface by reducing surface tensions and breaking up dirt or oil particles. Mechanism of detergency, surfactant break dirt or oil by reducing surface tension, allowing dispersion in water. Applications used in drug delivery, catalysis separation process, and chromatography. This is some key concept of surface and interfacial phenomena. So unit CGS, dynes per centimeter, SI unit Newtons per meter. Interface, liquid to liquid, liquid liquid, liquid gas in liquid, solid solid, solid gas, solid liquid. Surface free energy, energy is proportional to the size of the surface called as surface free energy. Method for surface and interfacial measurement, capillary rise method, Dewey ring method, drop weight and drop count method, and maximum bubble pressure method, that is a 4 method to determine the surface tension. Classification of surface active agent, wetting agent, emulsifying agent, foaming agent, detergent, solubilizing agent. Next most important question is asked in hydrophilic lipophilic balance. The HLB is a numerical system used to classify surfactant based on their balance between hydrophilic, water-loving and lipophilic, oil-loving properties. HLB range and applications: 0.3 antifoaming agent, highly lipophilic; 4 to 6 water in oil, WYO emulsifier; 7 to 9 wetting agent; 10 to 12 oil in water, O by W emulsifier; 13 to 15 detergent; 16 to 20 solubilizer, highly hydrophilic. HLB determine the solubility of surfactant to specific applications such as emulsification, detergency and solubilization. Help in selecting right emulsion for stable emulsion. Role: pharmaceutical formulation, particularly emulsion, creams, ointment and drug delivery system. So directly questions ask range of antifoaming agent, emulsifier, wetting agent 7 to 9, you have to remember. Maximum times GPAT questions ask which of the following range that is wetting agent, 5 to 6, 7 to 9. So you have to remember 7 to 9 the wetting agent, detergent 13 to 15, 16 to 20 solubilizer. So this is a range. So third unit is over. Now turn to the unit 4, complexations and protein binding. In that classification of complexations we have learn applications, method of analysis, protein binding, complexation and drug actions, thermodynamic treatments of stability constant. This point we'll learn. So with first GPAT multiple choice questions or competitive examinations questions we'll learn. First question, that is complexation is a process by which. Complexation is a process by which. Option A, the two molecules combine form single compound without any chemical bond. Two or more molecules or ions combine to form stable bases through the coordinate covalent bonds. C, a molecule loses an electron from positive ions. And D, liquid mixed together to form an emulsion. So option B is the correct answer. Complexation, formation of complex donor acceptor phenomena. Lewis acid base theory, I have heard about in first year. So proton donate, base accept. So donor accept, donate, that is the phenomena. The two or more molecule ions combine to form a stable basis through the coordinate covalent bonds, that is called complexation. Complexation means formation of complex between two molecules or ions. Next, which of the following is an application of complexation in drug therapy? A, decreasing the solubility of drugs to increase absorption. B, enhancing drug stability by forming a complex with stabilizer. C, increasing lipophilicity of drug to enhance solubility. D, none of the above. Enhancing drug stability, because not decrease the solubility. Cyclodextrin enhance the solubility. So first answer is cancer. Increasing lipophilicity of drug to enhance solubility. So option B is the correct. Enhances the drug's stability by forming a complex with stabilizer. Next, which of the following is the example of drug that form complex with metal ions from therapeutic purpose? A, aspirin. B, EDTA. C, penicillin. D, paracetamol. So aspirin is also drug analgesic purpose. Penicillin antibiotic. Paracetamol reduce the fever. So EDTA, ethylene diamine tetraacetic acid, is the example. Correct. Next, which of the following method is commonly used to determine the stability constant of complex? A, UV spectroscopy. B, flame photometry. C, TLC, thin layer chromatography. And D, none of these. Option A, UV spectroscopy is the correct answer. Next, in drug protein binding, the drug forms complex with plasma proteins. The complex drug is usually option E, inactive and cannot be exert therapeutic effect, more readily absorbed into tissue. B, and more active than free drug. D, inactive and excreted faster from body. Inactive and cannot show therapeutic effect. Protein binding drug form complex with plasma proteins. The complex drug is usually inactive. Next, which of the following is a common plasma protein that bind to drugs in the bloodstream? A, option hemoglobin, B, albumin, C, collagen, and D, insulin. So B is the correct answer. Albumin, globulin, and alpha glycoproteins that drug bind. So albumin here option. So albumin is the correct answer. Which of the following can affected by protein binding of drug? Option A, drug absorption, drug distribution, drug metabolism, and D, all of the above. Majorly drug distribution affect. B is the correct answer. Because drug is bind to the protein, blood proteins, blood present proteins, albumin, globulin, so that affect drug distribution. Next, complexation can increase drug action by A, decreasing the drug solubility and preventing absorption, B, enhancing therapeutic effect of drug, C, increasing the elimination of drug from the body, and D, changing the pharmacokinetics of drug by altering its distribution. Option D is the correct. Changing the pharmacokinetics of drug by altering its distribution. Next, which of the following drugs primarily interact with calcium to form a complex and affect its pharmacodynamic? Option A, magnesium sulfate. Option B, tetracycline. Option C, ibuprofen, and D, insulin. So tetracycline. Which of the following drugs primarily interact with calcium to form a complex and affect pharmacodynamics? Tetracycline. Tetracycline and milk. This combination, food drug interactions, I have heard about that. Chelation of bone defect, that is the side effect. Tetracycline and milk cannot be administered simultaneously. It causes drug interactions. Simultaneous administration of two drugs, one drug alters the actions of another drugs. So tetracycline and milk cannot administer simultaneously due to the bone defect, chelation of teeth, color change, that is the side effect. So that is a decrease the absorption of tetracycline. Calcium decrease absorption of tetracycline. Once absorption is decreases, the tetracycline cannot show the antibiotic actions. Complexation is a process of complex formation, that is process of characterizing the covalent or non-covalent interaction between two or more compounds. Another, complexes are a compound are mainly involved two components, i.e. ligand and metal ion. They are formed by donor acceptor mechanism, ligand and metal ions. Force involved in complex formation: covalent bond, coordinate covalent bond, hydrogen bond, van der Waals forces of dispersion, fifth dipole-dipole interactions. Classification: metal ion complexes, organic molecular complexes, inclusion oxygen compounds, metal ion complexes, chelates, inorganic types, olefin types, aromatic types, organic molecular complexes, quinhydron types, polymer types, caffeine and drug complexes, picric acid, inclusion oxygen compounds, layer types, channel lattices, macromolecular, and clarities. So these are the classification: metal ion complex, organic molecular, inclusion oxygen compounds. Metal complexes, inorganic complex, example EDTA complex, chelate, hemoglobin, organic molecular complex, drug polymer, inclusion complex, clarities, urea, hydrocarbons, cyclodextrin, drug complexes. Applications of complexation: solubility enhancement, stabilization, drug delivery system, bioliability enhancement, metal ion sequestration, chelating agent for detoxification. Methods analysis of complexations. Methods of continuous variation, distribution method, solubility methods, and pH titration method. That is a method of analysis of complexes. Methods of continuous variation, distribution method, solubility methods, and pH titration method. Method of continuous variation in that the change of physical properties such as dielectric constant, refractive index. Distribution method, when a solute complex with added substance, the solute distributed. Solubility method and pH titration method. That is the four method which have determined. Next, spectroscopy measures absorbance changes due to the complex formation. pH titration method measures the acid base concentration pH change during the titrations. Solubility method evaluate substance solubility in different solvent. NMR spectroscopy identifies structural arrangement. NMR signals. IR spectroscopy studies functional group interactions. Also detect incompatibility. Continuous variation method determine complex composition by varying components concentration. Distribution method studies solutes distribution between immiscible solvents. Protein binding. The phenomena of complex formation of drug with protein is called as protein binding of drug. Protein binding may be divided into protein plus drug, protein drug complex, albumin, alpha 1 acid glycoproteins. Protein bound drug is not immediately pharmacologically active because it cannot be interact with target. However, drug is still metabolized and excreted as unbound active fraction is gradually released from the protein. So protein binding, the phenomena of complex formation of drug with protein is called as protein binding of drug. Protein binding drug with example warfarin, anticoagulant, phenytoin, antiepileptic, diazepam, benzodiazepine category, sedative and hypnotics, aspirin, non-steroidal anti-inflammatory drugs, ibuprofen, NSAID. Complexations and drug actions, drug receptor interactions, chelation therapy, anti-cancer drug, prodrug design, thermodynamic treatment of stability constant. Stability constant indicates strength of complex formation. Equilibrium expressions K. Factor affecting stability, pH, temperature, ionic strength, solubility, pH, temperature, ionic strength, and solvent properties, not solubility. Point of equation. It explains temperature dependence. So this is about unit 4. Next, unit 5, pH buffer and acetonic solution. pH buffer and acetonic solution in that Sorensen's pH scale that explain pH scale up to 14, acidic, basic and neutral. Sorensen's pH scale, pH determination, electrometric method and calorimetric method. Applications of buffers, buffer equations, buffer capacity, buffer in pharmaceutical and biological system, buffer isotonic solution. So first question, the pH solution is measure of. The pH solution is measure of option A, the concentration of hydroxide ion, B, the concentration of hydrogen ions, option C, the solubility of substance in water, and D, the temperature of solution. So option B is the correct, the concentration of hydrogen ions. Which of the following is the correct range of for pH value in aqueous solution? Option E 0 to 14, option B 1 to 10, C 0 to 7, and D 4 to 9. So option A is the correct, 0 to 14. Next, Sorensen's pH scale is based on the measurement of A, the concentration of carbon dioxide in solution, the concentration of hydrogen ions in solution, B, C, the solubility of acid in solution, option D, the refractive index of solution. So concentration of hydrogen ions in a solution, that is the Sorensen's pH scale based on measurement. Next, which method of pH determination involve the use of pH electrodes and voltameter? A, calorimetrics, B, electrometric method, C, titration method, and D, conductometric method. So B is the correct, electrometric method. Next, which of the following methods uses a color change in a solution to determine the pH? So here questions. Which method pH determines involve the use of pH electrode, electrometric method. Here color. So C is the correct, colorimetric method. Next, a buffer solution is best described as a solution that A. Reduces the change in pH when small amount of acid or base are added. B. Changes its pH rapidly when acid or base is added. C. Has a pH of 7. D. Does not change its pH under any circumstances. So resist and change in pH when small amount of acid or base are added. That is called buffer solution. Next, the most commonly used buffer system in biological system: A. Acetic acid sodium acetate buffer. B. Phosphate buffer. C. Citric acid solution citric buffer. And D. Ammonium hydroxide and ammonium chloride buffer. Phosphate buffer is the correct answer. Next, the Henderson-Hasselbalch equation related to option A. The concentration of weak acid and its conjugate base to the pH of solution. B. The solubility of buffer in water. C. The buffer capacity and the pH of solution. D. The rate of reactions of acid and bases. A is correct. The concentration of weak acid and conjugate base of pH of solution. Have to remember Henderson-Hasselbalch equation related to the concentration of weak acid and conjugate base of pH of solution. Next, which of the following is the correct form of Henderson-Hasselbalch equation? A. pH pK log A minus HA. B. pH log HA plus Ka. pH HA plus A minus. D. None of these. Correct answer, that is A. Next, buffer capacity refers to A. The ability of buffer resist change in pH when small amount of acid or base added. B. The maximum concentration of acid or base that can be added to buffer. C. The pH at which buffer is most effective. And D. The time take to buffer stabilize after an acid or base is added. The ability of buffer resist change in pH when small amount of acid is added. Buffer capacity is the correct. Next, which of the following factors affect the buffer capacity? A. Concentration of buffer compound. B. pH of solution. D. Temperature. So D is the correct answer, all of the above. Next, in pharmaceutical formulation, buffer are used to control pH, improve the stability and solubility of drugs. B. Increase the rate of absorption of drug. C. Prevent degradation of drug at high temperature. And D. None of these. Control pH to improve the stability and solubility of drugs. Next, which of the following is a common physiological buffer system in blood? A. Bicarbonate buffer system, phosphate buffer system, ammonium buffer system, and D. None of these. Bicarbonate buffer system. Next, an isotonic solution is one that iso means same, tonic means concentration. An isotonic solution is one that option A has same osmotic pressure as another solution, usually body fluid, has higher osmotic pressure than body fluid. C. Has lower osmotic pressure than body fluid. D. Contains only water. Have same osmotic pressure as another solution, usually body fluid. That is isotonic solution. Iso means same, tonic means concentration. Next, which of the following solution is typically isotonic with human blood? Option A 0.9% NaCl normal saline. B 10% NaCl. C 5% glucose solution. D 1% NaCl solution. So 0.9% NaCl is typically isotonic with blood. Next, when preparing an isotonic solution for an IV injection, which factor must be considered? The pH of solution. B. Osmotic pressure of relative to blood. C. The temperature of the solution. And D. Color of the solution. The osmotic pressure of relative blood have to consider. pH buffers Sorensen scale 0 to 14. Next, applications: enhance the solubility, increase the stability. Buffer defined as compound that their presence in solution resist change in pH upon the addition of small quantities Buffer capacity is also called as defined as the ratio of increment of strong base or acid to the small change in pH. pH determination method, two methods, electrometric method and calorimetrics. pH determination electrometric method use glass electrodes and pH meter for precise measurement. Calorimetric use pH indicator and color chart for approximate measurement. Applications of buffer: pharmaceutical formulations maintain pH stability in solution and suspension. Biological system maintain physiological pH in blood. Example: bicarbonate. And analytical chemistry pH control during titrations and reactions. Isotonic solution, hypertonic solution, hypotonic solution and isotonic solution. Hypertonic solution, hyper means more than tonicity 10% NaCl, shrink cell by water efflux. Hypertonic solution 0.2% NaCl, swell cell by water influx. An isotonic solution 0.9% NaCl dextrose 5%, maintains cell integrity and hollow. Question paper of physical pharmaceutics. A 3 marks question will ask what are optically active substance. B define critical constant with example. Explain mechanism of detergency. Explain fixed first law diffusion. Next, state Bragg's equation. What do you understand by buffer capacity? Explain significance of van der Waals constant for real gases. 10 mark questions asked. Elaborate a Raoult's law and deviation with the help of example. Next, explain principal capillary rise method and drop pipette method for determination of surface tension. Write a note on spreading coefficient. Next, classify surfactant with example. Give HLB scale, hydrophilic lipophilic balance scale. Write a note on micelle solubilization. Next, explain Nernst distribution law and significance partition coefficient. Next, 5 mark questions. Explain phase diagram phenol water system. Explain about different methods of pH determination. Write a note on dissociation constant and application in pharmacy. Next, write a note on polymorphism, formation of more than polymorphism crystals. Explain Prender's-Langmuir adsorption isotherm, significance of biological buffers. Next, enlist factors affecting solubility of gases in liquids. Next, glass transition temperature. Elaborate colligative properties. Next, explain principle of liquefied propellant system in aerosol. These are the previous year question paper asked questions. Next, second paper, explain properties of ideal gases. State Bragg equation. Explain significance of van der Waals constant for real gases. State fixed first law of diffusion. Describe Sorensen's pH scale. Write about dielectric constant and dipole moment. Explain principle and method of liquefaction of gases. Write about working of aerosol. Explain Gibbs phase rule. Elaborate Raoult's law. Explain principle of capillary rise method, drop a pipette method, polymorphism, pharmaceutical biological buffer, glass transition temperature, protein binding, Dionering method, determination of surface tension, solute-solvent interactions, adsorption isotherm, method of crystal analysis, and surface free energy. Physical pharmaceutical practical, determination of solubility of drug at room temperature, determination of pK value of half neutralization Henderson-Hasselbalch equation, determination of partition coefficient. So these are the different practicals in your syllabus. These are the recommended books. So hope this video is helpful for you. Last, don't watch the clock too much. Focus on what you can do and keep going. Thank you for watching and believing in the power of development and learning. Hope this video is helpful. Thank you.